Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about definitions and terminology in the basic electrical engineering subject, Module 1. So that means Introduction to the Electrical Circuits. So in the first definition, so mention the reason for charge is bipolar. So charge is a bipolar. So because charge can be either positive or so that there may be a positive charge or negative charge. So we can call this charge is a bipolar. Next, second one, mention about the created by separation of charge created. So here for this particular one, so here there may be a separation of charge means here, so two plates. So here positive plate and negative place. Here the electric force is the voltage. So electric force is the voltage, and so that may be separated by charge. And whereas electric fluid is the current. So current means this current always flows from higher potential to the lower potential. If you compare with the current water analogy, also here water always flows from higher potential to the lower potential. Same fashion here, current is always higher level to the lower level. Water always flows. Same way here, current always flows from higher potential to the lower potential. So this current is created by motion of the charge. So here current is created by motion of the charge means, so motion, electrons flows from higher potential to the lower potential. So from the negative plate to the positive plate. So then current flows. So current is rate of dq by dt, rate of flow of charge. So that is electric fluid. So now next one. Next, third question. Define the resistance. Resistance means it will opposes the flow of current. That means DC current. So here if there is a resistor, this is the resistance. So it will opposes the flow of current. When current flows to the element, so here when it is current flows to the resistance, so this resistance opposes the property of material which opposes the flow of current. It will the opposing capacity of material against the current flow is the resistance. Next, fourth one, mention the fact KCL, Kirchhoff current law, is based on. So here at node, so in the this is the circuit, here this one. So at this node, this is some voltage. This is the voltage source V1, V2 and R1, R2, R3. Here suppose this is the node. So at this node there cannot be any accumulation of charge at node. So means, so here the node is not a circuit element. Circuit elements are resistors, inductors and capacitors, voltage sources and current source. Here charge must be if suppose charge is entering to the node, and that charge again must be leaves immediately. So this condition, so any charge which enters node and that must leaves immediately. So that one, so when it is enters and it should be leaves from the node. So this is regarding this KCL is based on this. Next, mention Kirchhoff voltage law. Kirchhoff law voltage law means algebraic sum of voltages in a loop equals to 0. So now here how many elements? 1, 2, 3. R1, R2, R3. Next, this one. This is the voltage source. Next, now here voltage across resistor R1 is VR1 and voltage across resistor R2 is VR2 and voltage across resistor R3 is VR3. Now here in any loop at any instant of time, algebraic sum of total voltages in a loop equals to 0. So the supply voltage plus VR1 plus VR2 plus VR3 equals to 0. Algebraic sum of total voltages in a loop equals to 0. Here supply voltage plus resistance drop plus resistance drop, R1, R2 and R3. But here depending on the current direction, this will be either positive or negative. Here this value is negative. So supply voltage equals to sum of the individual resistive drops. So now if you see the definition according to the KVL, the sum of voltages, not sum, algebraic sum of voltages around the closed loop in a network, in a circuit, in a loop equals to 0. This statement is most at any instant of time in a loop, in the circuit, in the loop. So algebraic sum of total voltages in a loop equals to 0. That one. Next, define a node. So here this is the network, 2 or more elements connected to one point. So here 3 elements connected to this point. So this point is known as the node. This point is known as a node. This point is a node. So if you see, the node is a junction where to our node is a point. So not this one. This is a node is a point where two or more than networks meets. So two or more elements connected to one point is known as node. Next, with what voltage in series resistor is replaced by source transformation? So series, so this is a voltage source in series with resistance. This is V and this is R, and this one is replaced by current source is replaced by open resistance R I. So now this I equals V by R and this V equals IR. So source transformation technique, voltage source in series with resistance is replaced by current source in parallel with resistance. Source transformation technique. So voltage source in series with resistance, this one, and current source in parallel with this one is parallel, same value. Next, source transformation technique is mainly based on which law? So Ohm's law is equal to V is equal to IR. Same thing. So this V is equal to IR. R and V is equal to IR. This is Ohm's law. And same way here current source. This is the R. This is the I. I equals to V by R. Same this formula. Ohm's law. According to the Ohm's law, source transformation technique is mainly based on which law? Ohm's law only. V is equal to IR or I equals to V by R. Next, 9th question. So which method is the best for voltage sources? Node voltage sources. That is nodal analysis method is the best for node voltage determination. Every voltage source is connected to the reference node that reduces the equations to be solved. That is a nodal analysis. Nodal analysis. Next, 10th question. So when there is a current source between two loops, which method is preferred? So when there is a, so here this one. So when there is a two current sources, so a current source between two terminals, this one and this one. This is the current source. So mesh 1, mesh 2 and mesh 3 in between two loops, there may be a current source. This is a current source, that is super mesh. For this particular case, we will use mesh analysis. So that this, when two current in between two loops, when current source exists, that is a super mesh. That concept we will use. So here super mesh is taken into the consideration when there is a current source in between two loops and is considered as a one single loop. So we will consider as a one single loop and we will apply KVL for loop 2 and loop 3. For both loops, we will apply KVL. We will consider as a single loop. So next, 11th one. If there are B number of branches and N number of nodes, how many node voltage equations? So that one is N minus 1. That depends on the number of nodes only, not branches. So that are preferred to that n minus 1 nodal equations are required to describe the circuit. Branches are nothing. So independent of number of branches. So node voltage equations are depending on the nodes only. So another one n minus 1 indicates, so another one is a reference node. So that reference node voltage is 0 in case of nodal analysis. Next, mention the unit of admittance. So admittance units are, so admittance is represented with Y, and that is reciprocal of impedance. So impedance units are ohms, and so admittance units are mhos or mho or mho. So are ohm inverse. So these three are the units of admittances. Units ohm inverse, and it is a unit of impedance is ohm, means that is reciprocal of impedance. So ohm inverse mho or mho. Next, what happen admittance when impedance increases? So always Y is the reciprocal of impedance. If impedance is increases and admittance will decreases. Now, here an impedance is increases, admittance decreases, because admittance equals to this 1 by Y equals to 1 by Z. Next, name the maximum value of wave during positive half cycle or maximum value of wave during negative half cycle. So this is the this one is one waveform. So this is a maximum value of positive half cycle, so maximum value, and this one is the negative maximum value. So this maximum value is known as a peak value. Here maximum value of wave during positive half cycle or maximum value, that one is peak value, this one. Next, name the area under the curve divided by distance curve is known as that one. This area under the curve divided by time period is known as average value. That one. The area under the complete curve divided by distance of the curve is known as the average value. The average value of sine wave over a complete one cycle is a 0, because positive half cycle and negative half cycle same. So for this particular case, so it is a symmetrical waveform. For symmetrical waveform, average value is 0. Now, so total 15 definitions and terminology in the introduction to the electrical circuits module 1. I hope all definitions are clear to you. If you still have any doubts, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.